Yes, hello everyone. So today we are discussing a question from mechanics. This is based on again shortest time, shortest path. We discuss this kind of question from that river crossing and all. It comes under that same category. Let's look at the question first. It says that a semi-cylindrical groove of radius r equals to 20 centimeter is made on a horizontal floor. An ant wants to cross the groove. A boy decides to help the ant, making a bridge consisting of a straight wire segments. But all the wires available are of length 38 centimeter. So the boy rigidly connects two wires at right angle and places the bridge in the groove as shown in the figure. Okay. If the ant can crawl up a wire segment at a speed of 0.5 centimeter per second and down a wire segment at a speed of twice that, then in what minimum time can the ant cross the groove with the help of this bridge? That's the question. So the ant wants to cross the groove in the smallest possible time. So let's see. How can we approach this question? So there is a groove first of all. Let's say this is the horizontal surface, and on the horizontal surface we are having a groove like this. Okay. And the ant would like to cross the groove. From here to there the ant would like to go. So during this process, the ant has to take the least amount of time, but the student is helping here, right? The student is helping by putting two wire segments, each of 38 centimeters, connected to each other at right angles like this. So I would like to put this wire segment here. So now I have a choice. I can put the wire segment in any way that I deem comfortable. But condition of the question is that I should keep the wire segment in such a way that the ant should take minimum time. So I could keep it in any position. I hope you understand. I can keep it like this, or I can keep it more towards this side like this, in this way. However I please, I can keep it, right? I can have different orientations of the same perpendicular wire, the V shape kind of wire, whatever I'm having, I can move it, right? Now to satisfy the condition, they have already given one data. The ant has a capacity of moving up this wire with some velocity, whereas while moving down it is having twice the velocity. So this is our key. This is where we have to think. We want the time to be minimum, so obviously don't you think we want the ant to move faster? And ant moves the fastest when it is climbing down. So if that is the case, then shouldn't we make the ant climb down in most of its journey? Because ant is faster while climbing down. So if ant is faster while climbing down, let it climb down in the most of its journey. So I'll change my orientation, and being a smart student here, what I would do, I would try to make the ant move in most of its journey down, and only the remaining part of the journey I would make it to climb up like this. So what I have done here is, this is the diameter of my groove, and how much is the radius they have given? The radius is 20 centimeter. Let this be the center. So this much is 20 centimeters. So total should be obviously 40 centimeter. I am arranging this rod in such a way that this length itself has become 38 centimeter. That means the maximum length I have given in downward motion, and remaining whatever length I have here, which is not really 38, it is something, let's call this as some x. This much length I am giving it in climbing, because climbing its velocity is less, and while coming down its velocity is high. So when the insect would be coming down from here, it will be having a velocity downwards as 2v, and while climbing up it will be having a velocity of v. So by keeping this arrangement, I have made sure that ant travels most of its distance down and a very less distance upwards. Okay, so with that now I can find out the time, and whatever time I am finding now will definitely be the minimum amount of time, and that will be distance by velocity. That's the formula. So distance would be what? 38 centimeters here. With what velocity it is traveling? 2v. And the other side, it is x distance, which I am not aware of, divided by the velocity would be v. But can I not write something for this x? We know that this is 90 degree. If this is 90, this much is 40, and this is 38, by using Pythagoras, we can get this as under root of 40 square minus 38 square, right? That logic we can use. So based on that, let me substitute. This is 38 by 2 times of v. What's the speed of the ant they give? 0.5 centimeters. So that means it's basically 1 by 2 centimeter per second, plus x value can be written as under root of 40 square minus 38 square divided by v, which is again 1 by 2. So this would give me 38 plus 2 times root of, I can use the formula a square minus b square, right? A plus b into a minus b. So I'll get 2 into addition would give me 78. So this should give me 38 plus 2 times of root of 6 and 156. Now what's the value of this? After calculation, I am getting 62.76 seconds. 97 seconds. 62.97 seconds would be the time that we get. So it's a simple question, but at the same time, a little logical. You have to think that if I want the time to be minimum, obviously in most of the journey, if possible, complete journey, the ant should have traveled with the same high speed, but that's not possible because diameter itself is 38 and the 40, and the maximum length that I have for the rod is 38. If possible, I would have just kept the rod exactly straight. Then the ant would have traveled most of its distance in the straight path with maximum velocity, but that's not possible. They said 38 is the length. Obviously, it has to come down a little and then only it has to climb up. So this is the possibility, or this is the arrangement for which it will get the least amount of time. I hope all of you have understood. Thank you very much.